Okay, here's one student asked me how to make an ROC curve when we have more than one um, possibility for the class variable. In other words, here we have three possibilities. This is Iris setosa, Iris versicolor, and Iris virginica. So you do the same thing actually. You just use an algorithm. For example, you can use naive Bayes here. Right click and threshold curve, and then you just choose one of these. You're going to get the ROC curve for just one of the classes, which is acceptable. Okay, so you can choose any one of them. So if I choose Virginica, I get this ROC curve. Now, this is a very good predictor, and you can see that here, right? There's virtually no errors, or very few errors. And so the area under the curve is very high, and so it looks like this. It's close to perfect. However, there are some errors here. You can see there are two errors there. Now, if we look at not Virginica, but this one, there are also some errors here. Here you can see there are 4 errors for this one, which is not many, but there are some. So we could say that there are some false positives, meaning there are some that were identified. This is identified. The column is identified. There are some that are identified as versicolor. This is B, versicolor, that actually are not versicolor. They're virginica. Okay, let's try with the other class, which is setosa. And here we see for this, it is perfect. And here you can also see that it's perfect. That is, there are no false positives. So you can show, actually, if you have just 3 classes, you could show all 3. But if you have many, many values for the class variable, more than just 3, then you could just show 1 or 2 or 3. And you can discuss them as well in the way that we just did. And it would be good if you could do it in Excel if possible. It just looks a little bit better, and you can label the axes more clearly. Of course, it's labeled up here, but it would be good to have it in a more standard layout. You don't have to do all of them in Excel, though. And additionally, in your discussion, you should discuss what these errors would mean for your particular data and why they would be important or not important for your particular data. So like we said, when you're talking about a cancer test, it's important that whether you get false positives or not, and also whether you get false negatives. And we talked about which is sort of more important, a false negative or a false positive in the case of cancer. So you should just make those kinds of points with your own data.